Okay, in today's video, I want to talk about what is a mole. Now, a mole can mean many things in our English language, but we'll talk about those and then we will finalize what is a mole in chemistry because that's what we need to understand. Now, the first thing you might think of when you think of a mole is that little guy that lives in the ground. We do have moles that live in the ground and they make a lot of holes in our yards and sometimes can cause a lot of problems. And they can be little cute little things, but that is not what we're talking about in chemistry. So is a mole an animal that lives in the ground? Not in chemistry, it's not. Is it a high school student? Do we have a high school student named Mole? No, it's not a high school student. Is it a mark on the human body? We do have moles on our body, but that is not what we're talking about in chemistry. So, as you can see, a mole can mean a lot of things, but in chemistry, a mole is a unit. That's it. It's just a unit. Nothing too exciting here. It's a unit, which means we're going to be doing some math. Okay, let's talk about a mole in chemistry and what it means. A mole is 6.02 times 10 to the 23rd particles. So when I say particles, it's either going to be atoms if we're talking about elements, it will be molecules if we're talking about covalent compounds like carbon dioxide, or it will be formula units if we're talking about an ionic compound like salt. So we can calculate the molar mass of salt, and to do that we need the periodic table. So salt is sodium and chlorine, and we get the mass of both of those elements, add them together, and we get 58.44. A mole of aluminum is 26.98 grams. Now, where does this number come from? This number comes from the periodic table. So find aluminum, which is number 13 on your periodic table, and you should see the number 26.98 in the box. A mole of tin is 118.71 grams. So if you find the box for tin on the periodic table, which is number 50, you will see 118.71. It will depend on where your periodic table rounded numbers, but it should be pretty close to that. A mole of gold is 196.97 grams. So find gold on your periodic table, number 79, and you should see 196.97. A mole of copper is 63.55 grams. So copper is number 29 on the periodic table. You find that box for copper, symbol is Cu, and you should see 63.55 grams. A mole is a unit of measurement in chemistry. It is used to measure the number of atoms, the number of molecules, or formula units in an element or a compound. It was discovered by Avogadro, and then we call it Avogadro's number. It is a unit of measure, just like our units. For example, we know that 1 dozen equals 12. So most people know that a dozen equals 12. So you go order a dozen donuts, you know that you're going to get 12. So we have the understanding. A mole is 6.02 times 10 to the 23rd. So let's kind of get this number in perspective if we can. It is a large number, so sometimes it's hard for us to comprehend how large that is. So I'm just going to go through some examples, and hopefully you will be able to see how large this number is. So if we had 6.02 times 10 to the 23rd watermelon seeds, those would be found inside a melon, slightly larger than the moon. So okay, so what does that mean? Okay, so pretend I had a melon slightly larger than the moon. Now think about that. A melon that's slightly larger than the moon. 6.02 times 10 to the 23rd watermelon seeds would fit inside. So hopefully, sometimes it's kind of hard to understand that, but hopefully you can see how large this number is. So let's talk about something else. What about donut holes? What if I had a mole of donut holes? Not a dozen, but a mole. Now remember, a mole is 6.02 times 10 to the 23rd. If I had that many donut holes, it would cover the earth and be 5 miles deep. It would cover the earth and be 5 miles deep. We would be swimming in donut holes. So we know that a dozen donut holes is 12 donuts. One case of donuts is 24 donuts. A gross of donuts is 144 donuts. If you didn't know what a gross is, now you do. It's 144. If we had a mole of donuts, that is 6.02 times 10 to the 23rd donuts, a huge amount. Now these sentences were talking about donuts, or these relationships. This up here, this one here is talking about donut holes. So they're a little bit smaller than donuts. All right, so let's talk about a mole of pennies. A mole of pennies is 6.02 times 10 to the 23rd. If I had a mole of pennies, I could make 7 stacks that would reach the moon. So let that sink in just a little bit. 7 stacks that would reach the moon. If we distributed a mole of pennies evenly to everyone in the world, everyone would have 1 trillion pennies. That's a lot of pennies. All right, well, what about a mole of sand? A mole of sand, once again, is 6.02 times 10 to the 23rd. If I had 6.02 times 10 to the 23rd grains of sand, that would be more than all the sand on the Miami beach. That's a lot of sand. Okay, what about a mole of blood cells? Once again, a mole of blood cells would be 6.02 times 10 to the 23rd. So what would that look like? It would be more than the total number of blood cells found in every human on Earth. That's a lot of blood cells. What about a mole of marshmallows? I like to roast marshmallows. A mole of marshmallows is 6.02 times 10 to the 23rd. If I had that many, it would cover the United States to a depth of about 650 miles. So let that kind of sink in. It would cover the United States to a depth of 6. What about a mole of rice grains? A mole of rice grains would be 6.02 times 10 to the 23rd. What that means is 6.02 times 10 to the 23rd rice grains is more grains than the number of grains of all grain grown since the beginning of time. So that would be a lot of rice. What about a mole of hockey pucks? Let's bring some sports into this. A mole of hockey pucks is 6.02 times 10 to the 23rd. If we had that many hockey pucks, we would have the volume of the moon in hockey pucks. So that is a lot of hockey pucks. We'd have to no, we wouldn't have to calculate the volume of the moon because we can look it up on Google. What about a mole of basketballs? So a mole of basketballs is 6.02 times 10 to the 23rd basketballs. And they would fit perfectly into a ball bag the size of the earth. I don't know if I could get a bag that large, but if we had a bag that was as large as the earth, a mole of basketballs would fit into it. So hopefully this kind of helped you understand the large number of what a mole is. We are going to be using this number a lot in chemistry and in stoichiometry and doing conversions.